Alright, great, welcome back. We are now going to be starting to talk about some more techniques. This is part 2 of 3 parts to this little lecture here. I just want to show you a little bit about printing. Now we have seen that DISP, display command, which can just dump the contents of a variable onto the screen, and that can be an awfully useful tool, but it can be more flexible to use the printing command. I mean, remember back in the previous lecture we had that hello world example where we just used a little printf statement to show hello world. We did something that looks like this, where we had printf, that's the print function, and then in parentheses we tell it what we want to see. In this case we want to literally see the letters W-O-W, and then that /n. The /n means move on to the next line, kind of like hitting enter in Word, or hitting the return key on a typewriter or something. It just means move on to the next line. Many, if not most, computer languages use that notation. It's a way to tell it, I'm done with this line. I'm not planning on putting something after the word wow on this same line, so just go ahead and move on to the next line. Perhaps more usefully in this class, though, you can use the printf statement to combine both text and some values. For example, what if you wanted to write on the screen, as part of project 1, to write on the screen, the sun angle is so many degrees. Alright, well then, you could literally printf, the sun angle is, then some code there, that %f, and then ./n, the dot is just the period in that sentence right there, /n. /n, of course, meaning move on to the next line, and then, after your close quotation marks there, comma, sun angle, where sun angle is something you've computed higher up in the program here. What will happen here is that %f will get replaced by the value of sun angle. %f means that this is a floating point number. From math classes, they would call that a real number. In contrast to integers or something like that, it'll have decimal points and so on. Let's just give that a little whirl here. Let me make a example 5.mat, and let's just make a simple little example here. How about pi is equal to 3.14159, printf, my value of pi is %f, %f, I don't know, just so you can see that there's something after that, /n pi. Alright, so what we're just doing here is we're printing to the screen here, my space valu, literally just putting this here, but when it hits %f, it'll just replace it with this value. Alright, let's actually give this a try. Save it, yes, exit, Octave, run example 5.mat. My value of pi is 3.14159, okay? Right? Pretty straightforward. Let me go ahead and get out of this here and show you something else. Let's say we had more than one value here. Let's just say we had another value here. I'll just say A is equal to 27.3. My value of pi is %f, and my value of A is %f. So there's pi, comma A. So the value of this first %f will get replaced by the value of pi, and this value of this second %f will get replaced by the second one. That'll be this A. So now if we run this, you'll see how that worked. Run example 5.mat. My value of pi is 3.14159, and my value of A is 27.33. Notice that they both have more digits than I started off with. I mean, my value of A was 27.33, not necessarily 27.33000000. We can control that. We can decide how many digits we want to show. If I go back into Nano here, the trick to do that here is between the % and the format specifier f, you can say how many digits you want by putting a dot and then a number. Like I want to show this to 4 digits. %.4f means 4 digits beyond the decimal point. Similar, we can do that with A here. Let's just say A will be 0.2. Okay, so we're going to be writing the value of pi to 4 digits beyond the decimal place, and we'll be writing the value of A to 2 digits beyond the decimal place. So we get out of there, run Octave, run example 5.mat, and my value of pi is 3.141 instead of 59, it rounded it to 6, and then my value of A is 27.33. Pretty straightforward. If the number you're showing is an integer instead of a floating point, let's get out of here, and go back and look at this here. Let's, oops, sorry, quit. There we are, Nano. let's just get rid of some of this here. What if my value, let's just say I was equal to 108. All right, my value of I is something. This format specifier for integers is D. I have no idea why it's D. I think %I works. We could test that if you want. But my value of I is D. And then let's just put the value of I will go into that. So your computer will write my space value of I is, and when it hits %D, it'll replace it with the value of I. Let's go ahead and save that and see if it works. Run example 5.mat. My value of I is 108. Okay, so for integers you use a slightly different format specifier. Let's go ahead and try that. Let's actually see if I never have been sure why integer is %D, but in most computer languages that do this kind of trick, %I is equivalent. Let me just go ahead and try that. I don't know if this will work. Let's try it. Run example 5.mat. My value of I is 108, yes. So apparently %I is a synonym for %D, and I might be easier to remember since it's an integer. Okay, another set of things that you need to do when you're writing a computer program is make decisions, like if this is true, then do that, otherwise do this. The syntax for that in MATLAB is if, else, and endif. And I'll show you examples of how to do that here. Look at this little blue box here. I've just set two constants here. I said A is equal to 3 and B is equal to 4. Now in practice you'd probably be doing a calculation there, you know, like sun angle is this and solar azimuth is that, or whatever for in the project 1. Then look at my test here. If A is greater than B, notice there's a condition here. A is greater than B. That is a statement, a condition. That is either true or that is false. Notice that the condition is put in parentheses right there. So if that condition is true, we're going to do the thing that is between if and else. So in this case, what it's going to do is it's going to write to the screen A is bigger. If it's not true, it'll do the part between else and endif. So if it's not the case that A is greater than B, then it'll write B is bigger. Okay? That's pretty straightforward. I think most people understand. Different computer languages like C and Fortran stuff have slightly different syntax as to how this is. Some of them you have to write the word then, you know, if this is true, then do this. But in Octave it's just if, and if that's true, then move on to the next line and do the stuff that's between if and else. Otherwise, do the stuff that's between else and endif. And strictly speaking, you don't have to have an else. I mean, if the only thing you want to do is if this is true, then do this. You don't have to have an else. I mean, just go ahead and just do the part between the if and the endif. That's no big deal. Okay, so that you can see how that would work right there. Now, when you're making these decisions here, what can be in that condition? Most of the time in this kind of class, it's going to be some kind of mathematical test, like greater than or less than. If A is greater than B, or if A is less than B. Those are perfectly normal examples of tests. You might need greater than or equals, or less than or equals. Okay, well, it's a little awkward, that greater than equal sign, or that less than equal sign, but once you know, okay, that's what they're looking for, it's not that big of a deal. Alright? But there is one weird one, and that is the equal sign. What if you wanted to test if A equals B? Okay, there is something strange about what Octave does, and in fact almost all computer languages have something strange about how they deal with equal sign. And this fundamentally stems from the fact of the stupidity of the English language. The computer is doing it right. There's going to be something weird about equals in English that is screwing up how you're thinking about what's going on here. See, we use the word equals in English to mean two very different things. Actually, more than two different things, but we'll get there later in the semester. One thing that we mean when we say equals is in like, take this and make it equal to that other thing. Pi equals 3.14159. I'm saying take this value, 3.14159, and put it into this variable that I call pi. Okay? That is setting a value. And in Octave, and in fact in most computer languages, the operator to do that is equals, as we have seen lots of times already this semester. A equals 3. That means you're taking the value 3 and you're saying set the variable A equal to that. But we use the word equals also in English when we're talking about a test. If A equals B, then go do something. But that's a very, very different thing, because you're not saying take the value that's in B and put it into A, you're saying do these match, okay? That is a failure of English. That is not a failure of computer language, that's two different things. When you are testing a value, if A equals B, what you really mean is an operator that in Octave and in fact in many computer languages is called equals equals, okay? If A equals B is a test. Does the value of A match the value in B? That's in contrast to A equals B. In fact, you can get yourself into a whole lot of nasty bugs with this, because if A equals B, as in you have that little equal sign, you just put 1, not 2, will actually work in the sense that what it'll do is it'll say, put the value of B into A, and if that worked, call that true. So that is a nasty bug that is hard to squish in your program, okay? Let me show you an example of that real quick. I'm just going to make another little example.mat program here. A equals 3, B equals 4. Let's go ahead and put those let me be more clear about that. I'm going to put this in Nano. I was using VI because I like VI better, but let's use the Nano text editor. Alright, so A is equal to B. Alright, if A equals B, let's just print they are the same. Else, printf, they are different. Endif. Notice, by the way, that much like a for loop, when we do an if, we usually indent a couple of characters just to make it more clear that this is inside of this statement. And also notice that in my example here, there's only one thing that's happening inside of this if, but in fact this could be a long chunk of code here. There could be lots of lines here. Alright, I think I can picture what's going to happen here. A is equal to 3, B is equal to 4. I have set the value of A to 3, I've set the value of B to 4. If they are the same, it'll write they are the same. Else, it'll write they are different. Let's run this program and see what happens. Save. Yes. Octave. Run example.mat. They are different. Okay. Let's go back into that program here. Let's say we had a little bug here. What if I had said, oh, I forgot about equals equals, I'm just going to put equals here. Seems like this should either work or crash. But watch what happens. Save. Yes. No. Octave. Run example. They are the same. Wait a minute. A is equal to 3, B is equal to 4. Why are they coming up? They are the same. Well, that's because something... Notice, by the way, it issued a warning. Warning. Suggest parentheses around a statement as truth value near line 5. Okay, that error doesn't mean much to me, except for the fact that I've seen it so many times over the years, I know this is warning me about this problem here. See, what happened here is, since this is not an equals equals, what happened is the value of B was put into A. A is now equal to B, which is 4. Look, let's try this here. Printf, just to show you here, the value of A is %f, A. Printf, the value of B is %f/n, B. Alright, let's just run this thing real quick here. Now, just looking at this program, and I've made this mistake 1,000 times, it looks like it's saying A is equal to 3, B is equal to 4. Around here, since we've never done anything, it seems like A should be equal to 3 and B should be equal to 4, but see here, we've put the value of B into A. And then this worked, so it called this true and did this thing right here that said they are the same. Watch. Run example.mat. They are the same because A is equal to 4 and B is equal to 4. Oh my gosh, what a terrible bug. This is very, very difficult to sort out. I mean, it's only because I've made the mistake thousands of times in my life that I always remember to check for equals equals. Equals equals is a test. It's saying true or false, A is equal to B. Now if I run this program, run example.mat, they are different. A is equal to 3 and B is equal to 4. Oh man, this is a bug that's hard to find. I'll be helping you all through the semester about stuff like that. In the meantime though, I want you to move on and try a second little program here. I want you to take a little quiz here where you say, alright, write a little Octave program that finds the only prime number between 100,000 and 100,010. What is that number? It's either 100,001, 100,003, 100,007, or 100,009. Now, that would be a hard problem if it weren't for the fact that Octave here is an interpreted language, and therefore it has a lot of nifty math features already built in, and one of those is prime. Is prime is a nifty little feature that's already built into Octave that just takes the number I, whatever you've put into it, and says, is this a prime number or not? True or false? So like your syntax, 3 of your lines of your program will look something like this. If, parentheses, because the condition always has to be in parentheses in Octave, if is prime I, then do something. Okay, like print to the screen I is a prime number, end if. This will probably be inside of a loop where you are, changing the value of I from like, what is my saying here, 100,000 to 100,010, okay? But this little is prime is just our first little introduction to the fact that there's actually tons of things. I mean, good grief, is prime was probably incredibly complicated. Determining whether a given integer is a prime number or not is a computationally complicated task that you and I don't want to do. But if I need to know it, I'm glad that Octave has an is prime function built in. C, Fortran, C++, Java, they don't have things like that. Alright, go ahead, give this a shot, then click on the answer that you decide on as one of the 4 links below here to move on to get some feedback about your answer.